Hopefully now that you've mastered questions 1 through 3, which involve shifting the graph up or down, we can start to look at other types of shifting in question number 4. In question number 4, it wants us again to make a table of values and to sketch a graph for this equation. You already might be making some hypotheses in your mind about what exactly this equation is going to do when it shifts, because you can tell this time there's a number inside of the parentheses with the x. If you can think back to other times that we've seen stuff like this, like parabola graphs for example, you might already be thinking that you have a good idea of what a number inside the parentheses is going to do when it shifts a graph. So keep that in mind. Whatever idea you have is probably a good starting point because it may end up being confirmed when you draw this graph for real. Now, just to make sure that we're starting from a place of real data, we're definitely going to create a table. That'll give us some dots to use, and once we plot the dots, we can see if our hypothesis is going to be correct. So it says in this one, x minus pi over 2 inside parentheses. And the trickiest part about this that I want to make sure we understand is that when we make the table, that means we have to subtract pi over 2 from our x and then find the height at that point. So you'll probably want to have a unit circle somewhat close to you and, of course, be able to kind of follow along with this idea. So in this problem, I'm going to start with 0 because this becomes sine of 0 minus pi over 2. Now that might seem like, wait, what do I do with that? So just think about this logically. Or if it's more helpful to you, pretend that pi over 2 is 90 degrees and see if that's more helpful. Some people actually find that converting these numbers to their degree measures actually makes the graph a little bit easier to picture because instead of working with pi's, we're working with more familiar numbers. And if you want to do that, I would say this is a good time to think about this. Think of this, for example, as sine of 0 minus 90 instead. If you're fine with the fractions, that's okay. But I know that negative fractions with pi can be kind of confusing. So if you feel more comfortable, call pi over 2 by its degree name, 90, and do the problem like this. I'll keep going with this just to try to make it easier. Sine of 0 minus 90 means sine of negative 90. And negative 90 is one of those weird coterminal situations where we have to add 360 in order to picture what's on the circle. So let me quickly clear my calculator of old things. And then let's see if we can think about sine of negative 90. Negative 90 plus 360 gives us 270. That's a coterminal angle I recognize. So I'll call this point 270 instead, and I'll look at my unit circle. At 270, the height, or sine, is negative 1. So I know that this first value is negative 1. Then I'm going to do the same thing for all of the other ones, and hopefully it'll get a little bit easier to work with some of these. For example, pi over 2, which is really 90 degrees, I'll plug in the 90 as my x, so that means I have sine of 90 minus 90. So again, I'm converting the pi over 2 in this problem to a 90, and that's why I ended up having this. X becomes 90 minus the 90 that was already there. So fortunately, this isn't even a coterminal problem. 90 minus 90 is just 0. So if I go to my unit circle, the height or the sine at 0 is 0. So I know the second value is 0. Then I'll do the same thing for pi, which is really at 180. That's going to be sine of 180 minus 90 if I go back to my equation. So 180 minus 90 is 90. That's a familiar number. The sine of 90, or the height at 90, is 1. So 1 will be my next value. Then I'll keep going, kind of running out of space here, but hopefully you can follow my logic. Sine of x in this one is 270 minus the original 90 from the equation. 270 minus 90 is 180. So that's a nice familiar number again. Here's 180. Sine, or height at 180, is 0. And then, of course, the last one, 2 pi, is 360. So sine 360 minus 90, because that was part of the original equation again. And 360 minus 90 is 270. So sine of 270 on my circle is down here at the bottom, -1. Which I probably should have realized was the same because I already did sine 270 from the very beginning. So now I have all of my points. Now I can make the graph. So using my table data, I'm going to plot the points quickly on my graph so I can visualize. 0, -1. Let's just check. 1 is 2 tick marks. So -1 is down here. Pi over 2, then 0. Pi, then 1. 3 pi over 2, then 0. And 2 pi, -1. Now this looks a little bit strange, but I can definitely tell it has kind of the same pattern. So I always seem to go from this kind of middle dot up, and then there's a middle dot again, so down. So we must infer that the next dot must be a middle dot, and then up, and then another middle dot, and then down. So I'm just kind of using the pattern as my guide. Then if I backtrack and continue the pattern backwards, I'm just kind of looking for a trend here. And if I can connect these dots, hopefully I can see that this does look a lot like the original graph that we've been drawing all along. It's definitely got that cyclical pattern to it. But more importantly, think about that hypothesis that you made a couple of minutes ago. What did you think that the x minus pi over 2 was going to do to the graph? Because if your hypothesis was along the lines of what x minus pi over 2 would do to a different graph, like a parabola, you might have thought about a horizontal shift. Horizontal meaning left or right. And if you're looking now at the pi over 2's thinking, okay, wait a minute, maybe a point at pi over 2 should be helpful, think about this for a moment. X minus, when we see it in a parentheses, usually means shifting the graph to the right. Remember how the x minus in parentheses always sort of does the opposite of what we would expect? So if x minus is telling my graph to go to the right, and pi over 2 is usually telling me the distance to go to the right, I'm actually not surprised then to see on my graph a point that is at pi over 2, shifted compared to where we originally used to start at 0, 0, to the right. So now that I'm thinking about this, this actually does make perfect sense. Usually the graph's at 0, 0. This graph, we didn't really know where to start, but it definitely has a point that is shifted to the right compared to what we would think, and it does seem as though our prediction would have indeed made sense. That the pi over 2 did indeed shift the graph right pi over 2 units. Now, if that does make sense to you because you've seen enough graphs by now to know that that's a common trend, then hopefully you can kind of estimate for yourself then what might happen if this said x plus in the parentheses. So let's consider that situation. If x minus is going to shift to the right, what do we think an x plus in the parentheses would do? As you turn the page to page 24, let's consider that possibility in number 5. In number 5, it says fill in the table of values and sketch a graph for the equation x plus pi. So I'll try to do this one a little bit more quickly, figuring that if you've kind of already got a hypothesis in your head, this might help confirm your hypothesis. And while it's certainly not going to be necessary to do a whole lot of work for these problems in the future, I'm still going to show my work here just so that way we can have something to go on, something to make sure that we understand where these points are coming from, so that when we make these hypotheses, it's based on real data. It's based on real numbers. Now again, if the pi's are confusing, especially if you're just not a fraction person by nature, you can quickly convert the whole problem to degrees. And that means the original equation would be x plus 180 degrees instead of pi, and that might be easier to deal with. So let's see if we can do this kind of quickly and see if making a hypothesis for this makes sense. Before I start plotting some data, consider either pausing the video or having a quick thought. Where do you think the starting point of this graph in number 5 is going to be? It's got an x plus and it has a pi. So think about the picture and think, where do you picture that yellow starting dot to be? While you're thinking about that, I'm going to start plotting some dots and we'll see if you're actually correct. If I start with 0, That would be sine of 0 plus 180. 0 plus 180 is 180. Sine of 180 is 0. This is me doing unit circle problems, but I'm going to have the unit circle off camera, so if you need to keep your unit circle near you so you can see where I'm getting these numbers from, please feel free to do so. And if you don't have a unit circle, you might want to quickly pause or take a screenshot of this video so that you can refer to the unit circle on the screen in case you need it. Now, sine 90. 90 plus 180 is 270, so sine of 270 is negative 1. 180 is plus 180, 360. Sine of 360 is 0. 270 is going to start to get kind of big, because 270 plus 180 is, let's see, 270 plus 180 is going to be 450. And sine 450, now I'm getting into coterminal stuff, so I want to quickly convert that number. 450 minus 360 is 90. Okay, so I'm going to convert that number. And sine of 90 is 1. The last one, 360. 360 plus 180 is going to be 540. Again, coterminal, because that's a little bit too big. 540 minus 360 is going to be 180. 180 is a value on the circle that I recognize. Sine 180 is going to be 0. I'm not surprised to see these numbers. You probably aren't either. So let's do some plotting, and let's see if your original hypothesis is going to end up being true. 0, 0 is here. Pi over 2, negative 1 is down. Pi 0 is back to the center. 3 pi over 2, 1 is up. 2 pi is 0, so center again, and I can definitely see the pattern continuing one more time. I've gone down and then back to the center, up and then back to the center. So we can assume down, back to the center, up, back to the center for the remaining points. Same thing in the opposite direction. If I keep the pattern going, I was up, then back to the center, down, back to the center. So the next tick mark must be up, and back to the center, backwards. Now that I can connect my dots, I can definitely tell, not surprisingly, that I have the same exact pattern that I always did. But now, think about that hypothesis that you made. Did you predict that the graph was going to shift to the left because of the x plus? And if so, did you predict it was going to shift to the left pi units? Because if that indeed was your prediction, you will be quite validated to notice that there is a point shifted from 0, 0 to the left pi units. And not surprisingly, that seems to fit the pattern that we've seen. So, if you wanted to generalize what effect the x plus pi had inside of the parentheses, it seemed to shift the graph, or the starting point, to the left pi units. So to summarize, x plus inside the parentheses shifts the graph to the left. X minus in the parentheses shifts the graph to the right. Now that we've kind of seen that shifting, let's try question number 6 and see if we can make some predictions without having to do all the table stuff. Just like in the previous video, I'll do the first one, you'll do the second one as independent practice. In the first one, it says x plus pi over 2. Just like in the example we did, x plus seems to tell me to go to the left, and pi over 2 seems to tell me where to go. So I'm going to go from the default starting position of 0, 0 to the left pi over 2. That is going to be my starting point. Now remember how the distance that we need to travel to get to our top dot, or our next dot, is that number in the front of the equation? I'm going to assume, because I don't see a number in the front, that there's a 1 there. So that's telling me by default then that from my starting dot I need to go up 1 unit to make the next one. After I go up 1 unit, then remember the pattern. Back to where we started, then down 1 unit, and back to where we started. So remember the pattern, up and back, down and back. If I keep that pattern going, up and back, down and back, up and back, and you'll probably run out of space, which is fine. Then you can have more dots to connect. If you wanted to connect the dots in reverse, up and back, down and back, up and back, down and back, then you can complete the cycles. You technically only have to draw one cycle to really be able to show that you know where the graph is, but these extra cycles might be helpful to draw just to complete the pattern. Again, if you like to highlight your starting dot so you can see it clearly, that might be helpful too, just so you can practice getting that idea of left versus right. If you haven't yet, try question letter B, and in question letter B, check your answer using the answer key provided on the learning plan to ensure that you've got the shifting idea down. In the last video, which we'll use for the bottom of the page problems, that's where we're going to put it all together. So before you take the time to finish the bottom of the page, do letter B, check your answers, and if you feel like you need some guidance in putting it all together, you can watch the final video on this playlist. If you feel like at this point you get it and you can do the rest of the problems without the video, feel free, as always, to work ahead.